All right, we're moving into chapter 5, talking about systems of equations. This first section, we're looking at how can we solve systems of equations by graphing. So first of all, what is a system of equations? Well, a system of equations is just when we have two equations with two variables. And here's what that looks like. So we've got y equals 3x minus 6 and y equals like negative 2x plus 4. So when we're talking about systems of equations, we're not just talking about like just random lines. We want to look at how are those lines related to one another. So when we're looking at two lines, we really have two options with them. One, they're either going to cross at some point, or two, they're not going to cross. So we know if two lines don't cross, that we're talking about parallel lines. Parallel lines are going to have the same slope. So if two equations do not have the same slope, that means that they're going to cross at some point, and that's what we care about. So if we look at these two equations here, we're going to graph it in Desmos. Let me pull up. Here it is. Okay, these are our two equations in Desmos. The red line is the first one, the blue line is the second one. And what I care about when I'm talking about systems of equations is I care about where they cross. So in this example, our equation crosses at the point 2, 0. So what we call that is we call that the solution of our system of equations. So the solution of a system of equation is an ordered pair, which we write ordered pairs as x, y, an ordered pair that is true for both equations. Okay, so we said that the solution to this one was the point 2, 0. That was the solution. And I can check that by plugging those numbers into my equations and seeing if it's true. So my y value is 0, my x value is 2. So I would have 0 equals 3 times 2 minus 6. Well, 3 times 2 is 6. 6 minus 6 is 0. That one checks out. Similarly, if I have 0 equals negative 2 times 2 plus 4, negative 2 times 2 is negative 4. Negative 4 plus 4 is also 0. So it checks out. That works out. That's what I mean. So when we're talking about a solution of a system of equations, if we want to check to see if an ordered pair is a solution, all I need to do is plug it into both equations and see if it works. If it does work, then it is a solution. If it doesn't work, then it is not a solution. So if we move on, your family opens a bed and breakfast. They spend $600 preparing a bedroom to rent. The cost to your family for food and utilities is $15 per night. They charge $75 per night to rent the bedroom. So first I need to write an equation that represents the cost. So what am I paying? Well, I can see that I pay $600 initially, and then I also pay $15 every night. So my first equation is just going to be y equals, I pay $600 initially, and then I pay another $15 every single night for utilities and food. That's it. That's the equation for my cost. Then it tells me that they charge $75 per night in order to rent it. So if I'm dealing with the revenue, all that's going to be is y equals $75 times however many nights. So letter C tells me that I want to write a system of linear equations to model this problem. This maybe seems a little bit like a complicated situation, but it is not. So all that this is asking me to do is essentially just list the two equations that I'm working with. So my system of equations is just y equals 600 plus 15x, and y equals 75x, right? That's it. That's all it's asking me for. All right, we go over to the next page. Now it's asking me to fill in the table for my cost and my revenue. So if you remember, our equations then are y equals 600 plus 15x and y equals 75x. Okay, so if we look at my cost, this is my cost. This is my revenue. I need to figure out what is it costing me in this table, and then also what's my revenue. So when it has been 0 nights, haven't had any nights, my cost, if I just plug that in, is going to be just the 600, right? 15 times 0 is just 0, plus 600. After 1 night, it's going to be 600 plus 15, 615. Next one is going to be 630. Right? It's just increasing by 15 every single time. So go ahead and fill in those values. So pause this now, fill in those values, and then you can come back and make sure that you have the right numbers with me when you're done. All right, so your numbers should look like this when we plug them all in. That's for our cost. So then our revenue is the y equals 75x. So at 0 days, we obviously don't have any revenue. After 1 day, we have $75. 2 days would put us up at $150. So this one is obviously just increasing by 75 every single time. So go ahead and fill in the rest of this table and then come back in when you're done with that. All right, so these are the numbers that you should have gotten in that scenario. So part E then is telling us, well, how many nights does a family need before they break even? So first of all, what does it mean to break even? Well, if we're going to break even, that means that we're essentially we come out to 0, right? So we're not making money, but we're also not losing money. That's break even. So really what we're looking for is, well, where are they the same? Well, they're the same over here at 10 days. So after 10 nights, I have broken even. I made $750, and it also cost me $750, so I have broken even. So let's look at this on Desmos then. If we come over here, let's see, we're done with that one. Leave. Okay, so here's our graph here, right? We said that we broke even after 10 nights, or at $750. And that's where you can see right here. That's where those two things intersect, is at that point. So this question is asking, well, what do you notice about the graphs? Well, our break-even point is where the lines cross. It's where the lines cross. And so that lines up with what we've been talking about, right? So if they're going to cross at some point, that means that they're going to have the same x value and the same y value. Well, you can see right here, right, that they have the same x value of 10, and they have the same y value of 750. So that means that the solution to this system of equations would be the point 10, 750. Right, that is the solution. After 10 nights, I have made $750, I have lost $750. Here's where this is useful or helpful, right? After this point at 750, what happens to my revenue? Well, my revenue, this blue line, is now way above my green line, right? So after that point, after my break-even point, is when I start to make more money than I spend. This is where the stuff comes into play, that it's super practical, right? Because this is what businesses want to know. They want to know, well, it cost me this much to make this product. How many of them do I need to sell before I start making money? That's what this tells us. Okay, so then this next part is asking us if a certain ordered pair is a solution of the system. So I have the system of equations. I have the ordered pair 3, 7, and I need to figure out, is this a solution to the system of equations? So I have the equation y equals 2x plus 1, and then I also have the equation 3x plus 4y equals 37. So in order to figure out if this is a solution, I need to plug 3, 7 into my equations and see if it makes them both true. So I'll have 7 equals 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7. Yep, this is true. That one works. I'll do the same thing over here. Let's do it this way. 3 times 3 plus 4 times 7. I want to know, does that equal 37? Well, 3 times 3 is 9. 4 times 7 is 28. 9 plus 28 is 37. 37 equals 37. This one also checks out. It is true. So 3, 7 is a solution. Something to pay attention to or to think about. We're dealing with straight lines. Are they going to intersect more than once? The answer to that is no. They are not going to intersect more than one time. So not only is this a solution, 3, 7 is the only solution to this system of equations because lines are only going to intersect one time. All right. So one of the things about graphing, especially by hand, when we're dealing with systems of equations, is you have to be careful. Make your graphs perfect. Okay, because if they're not perfect, what we're looking at is where do two lines intersect? Where do they cross? Well, if I mess up my line somehow, I'm going to get the wrong answer. So you really got to pay attention and make sure that you're doing it the right way. So I have the y equals negative x plus 5. I can look at that right away and decide, oh, well, I know that my y-intercept is 5. So I'm going to put a point up here at 5. My slope is negative 1, which means that I'm going to go down 1 to the right 1. So down 1 over 1, down 1 over 1, so on and so forth. I'm doing lots of dots because then I can draw my line a lot easier. So here is, this is what I mean, draw it perfect. There's that one. Here we go. That was better. Okay, there's the first line. Second line, y equals 2x minus 1. That means that my y-intercept is down here at negative 1. My slope is 2, so I'm going to go up 2 over 1. Up 2 over 1. Up 2 over 1. All right. Something like that. That one's not very good either, but we can see where they cross. So what we care about is this point right here, where they cross. Our 2 points cross at 2, 3. So the 0.23 is a solution to this system of equations. Okay? This one might feel a little bit trickier, oops, because it's not exactly in slope-intercept form yet, right? So we're going to have to fix that. So my first equation is 2x plus y equals 5. I want it to look like y equals mx plus b, right? So I want to get y by itself. So I'm going to do that by subtracting 2x from both sides. So then I'll have y equals 5 minus 2x. That's it. Here's my first equation. My second equation then, second equation is going to take a few more steps. So here I've got 3x minus 2y equals 5. Nope. Equals 4. Subtract 3x from both sides. I get negative 2y equals 4 minus 3x. We'll divide both sides by negative 2. Y equals 4 divided by negative 2 is just negative 2. I know that a negative divided by a negative is a positive. So plus 3 over 2x. Here is my second equation. Okay, so since I already have my blue one, I'm just going to grab this one first. Y-intercept is at negative 2. Slope is a positive 3 over 2, which means I'm going to go up 3 to the right 2. 1, 2, 3 over 2. 1, 2, 3 over 2. All right. Over 2. So my line looks like this. Okay, and then my other line, I have my y-intercept's up at 5, and my slope is negative 2. So I'm going to go down 2 to the right 1. Oop, that wasn't right. Down 2 to the right 1. Down 2 to the right 1. Down 2. Okay, that one is not as good as it should be, but here's my point of intersection right here. So then my point of intersection where it crosses is at the point 2, 1. Okay, so then this last page, this is asking me solve each system by using either the table or Desmos. You can forget GeoGebra. I thought about using it, but I don't think we're going to. So this first one, I have a lot of decimals in there. I don't really want to deal with decimals if I don't have to. So I think this is a good contender to use Desmos. Graphing this by hand wouldn't be very much fun either, I don't think, because of those decimals. So let's go ahead and, oops, find this in Desmos. Here we go. So I have the red line is the negative 4x minus 1.3. Blue line is 1.7x plus 4.7. And as you can see, these two lines intersect at the point negative 1, 3. So if we go back to our thing here, my solution is negative 1, 3. And I can test that by plugging those values into each of those equations. So in the first one, I would have 3 equals negative 4.3 times negative 1 minus 1.3. So I would have negative 4.3 times negative 1 is going to be a positive 4.3. 4.3 minus 1.3 is going to give me 3. 3 equals 3. We're good. If I do it for the other one, I have 3 equals 1.7 times negative 1 plus 4.7. So I would have negative 1 times 1.7 is just negative 1.7 plus 4.7 is also going to give me 3. So that one works. Number 2 is pretty easy to figure out on our own. So let's go ahead and start. Let's do like -2, -1, 0, 1, 2, 3. So when x is -2 for the first equation is just y equals x. So that means it's also going to be -2. This one's super easy. We can just fill these in. They're going to be the same. Second equation is -3x plus 8. So when x is -2, I would have -2 times -3, which is a positive 6. And then 6 plus 8 is going to be 14. And I know that the slope of this one is -3. That means that my values are decreasing by 3 every single time. So I can just subtract. So my next one then is going to be 11. At 0, it's going to be 8. Another 3 is going to be 5. 3 more is going to be 2. And then 3 more from that is going to be -1. So here's my table. Our goal then is to identify where our lines cross. And the way we figure out our point of intersection is where their y values are the same. So if we look, right, our y values are the same right here. Right, they're both 2. And this is coincidental, but our x value is also 2. So if I want the solution to this system of equations, my solution is that when x is 2, both of the y values are also 2. Okay? This last one is a little bit tricky. This is another one where we can, you know what, let's do this. -3, -2, -1, 0, 1, 2. Here's what I want you to do. On your own, I want you to figure out what do the y values equal. So fill in this chart as it is, and then come back here and we're going to talk a little bit about what you have come up with. Okay, these are the values that you should have gotten if you plugged in your numbers correctly into the equations. Here's what I kind of want you to notice. So if we're looking at a graph, right, here's a graph. Our y values are on the vertical axis, our x values are on the horizontal axis. So I want you to kind of pay attention to where the y values switch. So initially, when I'm over here at -3, my y1 value here is positive, right? And my y2 value is negative. Still positive, still negative. Something happens here, right? 0 isn't positive or negative, but it's something, right? It's not positive or negative, but it is kind of a shift. Our negative now has become positive, though. Now this is positive, this is negative, that's positive, that's negative, that's positive, that's negative. So none of our values have ended up being the same yet, but there is something that took place between -2 and -1. So that might be kind of a good indication that that's where the crossover happened. This one just is a little tricky because it looks like it would be a lot simpler than it actually is. So if we look at this one on a graph, it's my last one here. Oh, nope, I think I got rid of that one maybe. I did. Let's just do this quick then. Desmos. Okay, so we had what? Y equals -x minus 5. Nope, -x minus 1. And y equals 3x plus 5. Okay, so let me get this in I'm gonna zoom in a little, get this in projector mode so you can see it a little better. Okay, our two lines cross, but they cross at -1.5 and 1/2. So if you look at the red line is our, the first equation, right? And if we come back over here, our first equation, we saw the shift happen between -2 and -1, right? So it goes positive, positive, 0, oop, now it's in the negatives. So we come back and look at this, right? We're like, oh, positive at -1. Let's see, where am I looking? Oh, the red one. Oh, here, that's what I've zoomed in, that's why. Okay, positive at -1, and now it's negative over here at -2, right? So something happened in between there. Same thing with the red one, or the blue one, right? Something shifts between -1 and -2. So our solution for this system of equations then is the point -1.5, 0.5, which isn't very intuitive when you first start thinking about it. All right, last one. The test has 20 questions worth 100 points. The test consists of X true-false questions worth 4 points each, and Y multiple choice questions worth 8 points each. How many of each type of question are on the test? So, we've got a couple pieces of information here. First thing I know is that there are 20 questions on the test. There are X true-false questions, and there are Y multiple choice questions. So that means that when I add together my multiple choice and my true-false questions, should give me 20, right? There's 20 total questions. That's my first equation. Another equation that I have then is 4x. Each of the true-false questions are worth 4 points each. 4 times x plus 8 times y is going to equal 100. Okay, so we have our two, this is our system of equations. We have our two equations. Now you have a graph on yours. I don't know why it didn't show up on mine. But your graph goes from 0 to 18, I believe. Now, here's the tricky part, right? We have what seem like pretty straightforward equations, but if we solve the second one to be in slope-intercept form, first I would get rid of my 4x. So it would be 100, nope, I don't want that. It would be 8y equals 100 minus 4x, right? Divide everything by 8. You end up getting y equals 12.5x minus 1/2x. We'll just do 0.5 because I'm going to keep it consistent. Does that look like a very easy equation to graph on this? Not really, right? So this is where being accurate really comes into play. It would be pretty difficult to be super accurate on the graph that you're given. But if we come over here and we graph it in Desmos, it's going to be pretty simple to make sure that we have the right answer. So it intersects here, oops, at 15.5. So if I come back over here, my solution is 15.5. But what is the question asking me? The question is asking me how many of each type of question are on the test. Well, my x values represent the true-false questions. So what this means is that there are 15 true-false, and then there are 5 multiple choice. And we can check our answer, right? We knew that x plus y was going to equal 20. We figured that out over here. X plus y needs to equal 20. So if I have 15 true-false questions and I have 5 multiple choice questions, that gives me a total of 20 questions on the test. Similarly, if I wanted to plug those into the second equation, 4x plus 8y equals 100, well, 4 times 15 is 60, 8 times 5 is 40, 60 plus 40 is 100, right? So that proves it, that this is our solution to this last problem.